this topic of flow is something that a lot of people really wanted to hear about. I think it was one of our top rated things when we asked people to vote on stuff. So I'll turn it over to Mike and go for it. Appreciate you coming today.
Hey, thanks, Mark. So, like Mark said, we're going to talk about flow, and it's not necessarily flowing water like we have here. But if nothing else if you don't remember anything else from today, there's one phrase that I'd like you to remember, and it's this: focus on the work, not on the worker. And so the question might be now, like, what does that mean? Like, what is the work? So today, like Mark said, we're going to be talking about focus on flow, which is putting lean principles in action. So when we talk about lean and we talk about flow, what we're often talking about is we want to go from concept to cash, right? So we have some idea, something we want to do or build, but then we want to actually realize that at some point in terms of like actual profit or return. So in order to do that, we want to do this when I started out with, we want to focus on the work, not on the worker. So the work in this case is often what we'll refer to as the flow unit. And the flow unit is something that's going to provide value. So in this case, focusing on flow or focusing on the work is focusing on the value. So what does it mean then to focus on the value? So I'm going to use an example here of a kitchen. So if I'm in a professional kitchen, there's lots of things I could focus on. For example, there are measuring spoons and measuring cups. I could make sure that those devices are maximally utilized, that we're always measuring something to make sure that they are, again, like always in use. Probably less useful, but it's something we could do, something we focus on. We could look at the knives. Knives are more expensive than those measuring instruments and take more maintenance, but like, do we want our knives to be constantly going? Maybe, but maybe that's not exactly where we'd focus. Maybe closer is, okay, well, we're gonna have a bunch of pans. Maybe we wanna make sure those pans are being used effectively. If they are a scarce resource, then potentially that's useful. But again, this isn't still not quite the work, right? It's not the flow unit. The burner, right? We could make sure that, maybe we don't need to have all the pans in flight at the same time, but maybe we want to have all the burners working at any given time. Might be useful. And then we have an array of other instruments, right? And I specifically said focus on the work, not on the worker. Like in the kitchen, we actually have workers. Like, should we focus on them? Should we make sure that they are busy the whole time? Now, some of you might be familiar with this game. This game is called Overcooked. If you've ever played it, it is one of the fastest ways I've found to get me and my kids yelling at each other. And it is fun and also a super great example of how to organize systems and think in terms of kind of a lean flow. In this case, right in the upper left-hand corner, you have orders coming in, and then throughout the area, you have different ingredients and different ways to prepare them, and then you need to eventually assemble them and then deliver them to the customer. So again, it's that idea of like, okay, we have an order, concept, and then we want to get it delivered, which is cash. And so we could say that a delivered dish, right? Like the idea of like all the different things that go into it, we want to make sure that the dish actually delivers. And that in a kitchen is the work, right? A completed dish is the work of the kitchen. If for example, on this particular plate, if everything was there except for the piece of meat, like that would not add any value necessarily. I mean, it could potentially, but it is not what was requested. It wasn't what was ordered. It wasn't the concept that was originally there. And so therefore, is probably going to be unsatisfying to the person who receives the plate if they're missing their meat. So if we take this idea, when is that plate done, right? Because we could say, I'm in the kitchen, and so once it's all plated and it's sitting there ready to go, that's when it's done. But in reality, if I'm looking at the broader system, if it's sitting there and the person who ordered it is still out there at their table waiting, that has not yet actually realized value. So we could think about it in terms of from the time the customer orders to the time that the dish is on the table, right? That could be one potential like flow, when it's done, right? When it actually gets to the table. That being said, we might also expand it, right? So, sometimes we dine alone at a restaurant, but oftentimes we're with other people. So if we're with other people, if I'm at a restaurant, I want to make sure that everybody is eating together, enjoying their meal together, and that we can have conversation. There's often awkward if somebody's meal comes out really late or really early. So in this particular case, we want to go from when the whole party orders to when all the dishes are on the table. And this is partly because in a restaurant setting, we could think of the dishes as the work, and in a certain context they are, and this is part of the nuance here, is like sometimes we're focusing on the dish, but in a restaurant setting, what we're really focused on is the table. The table is the unit that's actually generating the revenue. So really what we want to look at is from when the party is seated until the party leaves. That whole process that is all around this idea of like, okay, from the time that somebody comes in the door to when they actually are leaving, that real estate of that table that is somebody seated at it is really important, because one of the metrics that's often used in restaurants is the idea of like basically how much revenue is generated per table per hour or per seat per hour. So again, we're looking at how much cash is going to be generated by that particular valuable unit of space. So every delay that is introduced is going to cost us. But in this case, the cost of delay is like if we're not able to get somebody seated quickly, then or the longer it takes to deliver the dishes, all of these different pieces of the whole system. If there's any delay, there's cost associated with that. So we want to understand the impact of time on our outcomes, usually in terms of money per period of time. Okay, so all of that, right? We have this example of a restaurant. So how does that actually apply? So we're going to talk about lean. So let's define what lean is. So we talked about concept to cash. The thing that is problematic with the term lean generally in our industry is that it is used to describe everything. And the problem why this happens is because there's no single generally accepted definition of lean. It is what is sometimes referred to as a suitcase word, meaning that people can pack whatever meaning they want inside that particular word. It's so generic that some people will say, "Well, I'm trying to get my process lean," but really what they're talking about is reducing cost, which could be a byproduct of doing some lean things. But again, it's a word that's rife with a lot of for misunderstanding. So the problem with suitcase words is often that you end up with this kind of tautology that everything lean is everything good and everything good is lean. You'll see this with the word agile sometimes as well. It's like, well, like it's agile if I think it's good, and then everything that is good, I'm going to call agile. And the same thing happens with lean. Same thing happens with a lot of different things. So it's not unique here, but it is something to be aware of as you're looking potentially for resources around lean. So I kind of said what it's not. So what is it then? Some people might tell you that it's a Toyota production system, and they wouldn't necessarily be wrong. The Toyota production system is a manifestation of lean, and probably honestly kind of in the opposite direction. Like the word lean came out of the developments within the Toyota production system, but it's not the Toyota production system as necessarily. There's lean startup, which again is super valuable. Build, measure, learn, super important. But is that by itself lean? So the thing is that if lean is defined as methods, the use of these methods becomes the goal. And think about this. If lean is defined as the methods, the use of these methods becomes the goal itself. And this is where it becomes problematic, right? So if we think about, I'm going to implement the Toyota production system, and that will make me lean. Well, maybe to a certain degree. I mean, there are many examples of people trying to, like GM, like went to Japan, went to Toyota, observed everything, basically put all of the mechanisms in place, like copying what Toyota was doing, but couldn't quite. They had the methods or kind of some of the details, but they didn't have. They still were not lean. So, so what is lean then? For the purposes of today, again, with all of these potential different ways we can interpret it, the part of lean, at least one of the core parts of lean for me, is this idea of flow efficiency. And the idea of flow efficiency is that we are going to apply the effort and attention of all of our resources onto the flow unit. So instead of, again, focusing on the work, the flow unit, and not on the workers or the resources in this case. So another example, right? We have the kitchen as an example. Another example is a relay race. So in a relay race, we will focus as we watch on the runners. But the real goal, real work, is not to get the runners around the track. It is to get, if we, again, like what we want to do is focus on the work, not the worker. So in this case, the runners are the workers, but the work is the baton. The baton is the thing that needs to actually make it around the track multiple times in order for you to be successful in a relay race. So if we focus on the work, not on the workers, we're going to define lean, again, not completely, but we're going to define lean as attempting to become more flow efficient. And flow efficiency we'll define as value added time divided by the total time. So, so in case like the value added time is time that is like we would call value added time the time that we actually work on something, versus the total time is, say, the clock time, or from the time that we start working on something to the time that it is actually completed. So I'm going to use another example, and this time it's going to be more relevant to software. So if we're looking at flow efficiency, let's say, for example, the example here we'll use is a defect is reported. Let's say by a customer. And so a defect is reported. We're going to say that it's going to take about 30 minutes to like figure out, like come up with some reproducible steps, get it entered into the bug tracking system, and then it's going to go into the system. in our example here, it takes about 30 minutes to do that, and then it's going to go sit in the bug tracking system. Let's say optimistically, like there's a programmer that is kind of tasked with looking at these things. Maybe they're working on something else. Who knows? Or maybe who knows what they're doing, right? But 4 hours later, the bug comes to their attention. They're like, oh, let's go ahead and work on it. So they pull that out of the defect tracking system, and then it takes them about 6 hours to solve whatever problem. Again, we're not going to look at the details of that, but let's say they actually work on it for about 6 hours. It's great. Okay, well, before they deploy it, they want to have it tested, right? This is a particular, we'll say that they have manual testers, and maybe they have some automated tests as well, but in this case, the process is to have a manual tester look at it. So the bug goes into the next state, it waits for a tester. Let's say it takes them about 4 hours to figure out, oh, look, it's something they want to do. They pull it. It takes them about 2 hours to do a manual test. And then we need to deploy it. So they put it back in the queue, and then it's waiting for ops. And ops needs to deploy it. Let's say wait another 4 hours, and then the fix is deployed. And maybe it's a manual process, but it takes about a half hour. So in this case, right, we've had value added time or work time of 9 hours. Whether that's long, whether that's short, who's to know, right? We don't know the details of this, but let's just say it's 9 hours. Now, we also had 12 hours of wait time where the work, again, if we're focusing on the work and watching the work go from station to station and from person to person, the work, for cameras on the work, the camera was just sitting there watching the work sit for 12 hours while it was while the camera was on the work for 9 hours. It was actually getting worked on. So what we can do is say, okay, we have 9 hours, and then we have 12 hours plus 9 hours, and what we end up with 53 or 43%. Is that good? Is that bad? Can we really measure this? Oftentimes, that's a whole nother discussion, but we're just using this for illustrative purposes. So let's say realistically, right, like we didn't work continuously, like we did not have people continuously working for all of that 9 plus 12 hours. And if we're really saying what we want to look at is clock time, we also have overnight to take into account. And in this case, because of the delays and the waiting time, we're going to have to go overnight twice, which is going to make it even more costly. Now, what if instead, again, if we focused on the work, not on the workers, right? Because one way we could make this faster, right? We could say, okay, developer, you need to, get twice as fast. You need to get that done in 3 hours instead of 6 hours. Well, that's not going to demonstrably change the overall time that it's going to be actually that it's going to take to actually get it out. And again, this is part of why we often focus on the wrong things. But if instead we say, okay, we're focusing on the work, when the defect comes in, instead of just having the support engineer like try to reproduce the steps and stuff, they actually pull the programmer over and say, hey, let's work on this together. The programmer goes off, works on it for 6 hours, like immediately hands it off, right? There's a handoff there, but it's more seamless, and there's no wait time. And then the programmer finishes up their work, and they know which tester is probably going to test this part of the system. They go try to find them, and they're like, oh, well, this tester's in a meeting. So I'm going to, again, like if I'm worried about my efficiency, like how much I'm working, I'm going to go and start working on something else, which means that I'm maybe going to forget, I'm going to lose track of this particular work. But instead, if I say, I'm just going to sit outside the, if we were in person, I'm going to sit outside the meeting and wait for them to come out, or give myself a reminder or chat them or whatever, so they know when they get out of the meeting that that it's ready to go. Then we're going to just maybe say it's a half hour, right? Still takes 2 hours to fix, half hour to, again, ops is maybe in some other meeting, we need to wait a half hour. So again, we've reduced the amount of wait time considerably by just again, focusing on the work, having the work move through, as opposed to worrying about like, well, I don't want to interrupt this person, or I don't want to like make them less efficient. I want to make sure that the work is efficiently flowing through the system. And so in this case, we're at like 90% flow efficiency, which is cool. Now, theoretically, we could get to 100% if we said the programmer went directly into the meeting the tester and said, hey, it's ready to go, right? And this could be possible if like the fix or the problem is like super duper urgent, right? Like it's affecting customers, it's like cascading, or having, whatever problems are going on. And again, in that case, like you're not going to wait for the end of the meeting. You're going to interrupt the meeting. You're going to get the tester. You're going to get the ops person. And again, it still takes 9 hours, but now we're at 100% flow efficiency because we have reduced our wait time basically to 0. So again, this is a byproduct of us focusing on the work, not on the worker. Like I said, nobody worked faster, but the more important thing is that the work was done sooner. The work was done within 9 hours as opposed to 9 plus 12 or 9 plus 1 or 9 plus whatever. Again, yeah. So I don't know, the silly example that I often share with people is this like pair programming. It's like people think like, well, like 2 people are doing the job of 1. Well, like 2 people can lift more than 1 can as well. So again, that idea of like we're focusing on the workers, like are all the programmers doing exactly what we wanted them to do at any given time, or do we focus on the work and make sure the work is progressing? Okay, so you might be wondering, there's a lot of different things that are associated with lean, small batches, WIP limits, all these things. So are these part of what we're going to talk about? Maybe, but again, the core thing is that we want all of our resources to be focused on the flow unit, because again, the alternative, which I've kind of talked about it already a little bit, is this idea of resource efficiency. Resource efficiency is where we load up all of the people on a project so that they are always busy, right? Because we're like, there's an idea of that, like the people are often the most expensive part of a project, especially in software. And so it's like, well, we need to keep them busy and keep them occupied. The There's many problems with that. But again, it depends on what your goal is. If your goal is to keep people busy, then sure. But the problem is that what happens is we have this, again, like any good presentation, we have a 2x2. But we have the idea of like, okay, if we have resource efficiency over here, we have flow efficiency down here, right? Obviously, the ideal is to have both flow efficiency and resource efficiency, right? Like here defined as being lean, this perfect state of both. The challenge is that often we end up over here in the efficient islands where everybody is working like to the best of their ability and maybe at full capacity, but again, work isn't getting done. And so paradoxically, focusing on utilizing resources efficiently tends to increase the amount of work there is to do without adding value. It's not that necessarily there's this idea of make work, but like you kind of just fill time with things that are maybe not the highest value, maybe not even valuable because there's no, yeah, and really what happens is this idea of like, okay, if I'm trying to use all the resources, in this case, right, we can see that pavement is at like 90% utilized. And if we're trying to utilize, a highway at 100% utilization is also known as a parking lot. And you can even if we say, okay, we're not worried about utilizing the pavement, but in this case, all of the cars are being utilized, right? But maybe the cars aren't moving. And so the point is not to have utilization. The point is to have flow or movement. So I live outside Atlanta, Georgia, and we are, I don't know, there's a lot of places like this, but we are pretty notorious for our traffic here. And this was a couple years ago. This is actually at one of the exits. It was under construction, but still, this kind of is emblematic of this idea. Is like this exit is getting used by 3 cars. That is pretty high utilization, but they are not going anywhere. And so again, we do not have things flowing. It's just one of those things in Atlanta traffic that you will find certain drivers like want to make use of every ounce of asphalt they are able to, which again does not necessarily lead to the traffic flowing well. Okay, so you might be thinking, okay, we're in Efficient Islands. We want to get to lean. Let's just go there. Well, the problem is that path from Efficient Islands to lean is basically inaccessible. Really, what often has to happen is you need to dip into less resource efficiency for a time, focus on flow efficiency, and then once you have flow efficiency, then you can start working your way up to thinking about how you might make your use of resources efficient. I honestly hate talking about people as resources, but this is just the nomenclature that is used within the lean community in terms of like, because we could be talking about machines, and a lot of times in manufacturing, that's what we're talking about. So how do we do that? How do we, if we're saying, okay, well, we're going to reduce resource efficiency, we still need to figure out how we're going to move right here. We're going to move at least to the efficient ocean to where we're more flow efficient. So there are a lot of different tools that you can use. One I'm going to focus on today is eliminating waste. And so there are 7 wastes defined in lean manufacturing circles, and we are going to look at what the software equivalent of each of those might be. So we're going to start with these 7 wastes, and these come from the Poppendix book, Lean Software Development and Agile Toolkit, which I actually have a copy right here. It is an excellent book, and again, gives you many, many more tools than what we're going to talk about today. So number 1 is partially done work. This one is difficult. So when partially done work is waiting for capacity to become available, the duration of the overall project will grow, which seems to make sense, right? If you're waiting, then it's going to grow. But those queues, like work waiting that's partially completed, also delays feedback, which then causes other delays in terms of potential other types of waste. So, for example, like in the physical world, when we're dealing with partially done work, usually we talk about it in terms of inventory. And so you have inventory on the shelves of, let's say, in this case, a convenience store or supermarket, right? All of that inventory is a form of waste, right? Now, some waste is okay, but in this case, right, we wouldn't want the shelves to be empty, but we would want things to appear on the shelf as soon as they're needed. And so we have a little bit of buffer there, but this inventory is really costly to a supermarket or potentially to a warehouse, right? Not only do you have to have space for it, you have to manage it, you have to make sure that it doesn't expire, you have to, in the case of something like a warehouse, you have to track it to make sure it's in the right place. I many years ago had a summer job working at a warehouse where they managed faucet parts, and they had to basically on the daily part. My job was to compile lists of what the current software thought was in the inventory so that people could go out and actually check on the inventory to make sure that they had accurate numbers. Because again, and not only do you have to track it in terms of like know where it is, but also you need to know how much there is. So you know when to reorder. You also have to know like, do I have enough to fulfill this order? All of these things, right? In a physical environment that make inventory difficult. In a software system, or a system that's producing software, there are lots of different types of partially done work, right? You could say anytime you've written any documentation for something that hasn't yet been coded, that is partially done work, right? Anytime you have code on a branch that hasn't been synchronized, that hasn't been integrated, that is partially done work. Code that hasn't been tested, either automated or manual or however you want to need to test your code. If documentation is necessary, right? That's also partially done work if you don't have it documented. And the big thing, right, is if the code isn't actually even deployed, right? Up until it's deployed, it's still partially done work. And so you have all of these places where you could have partially done work in your system. So the main way you can fight this is by limiting your work in process, by limiting your WIP. It's like the thing is that it's really easy when something gets stuck to be like, especially in a information system like we have, the inventory is essentially invisible. There aren't piles of pieces and parts laying around there. It's just simply like it's in Confluence or the wiki or SharePoint or whatever system you might have. Like you have all these documents that people have produced, or even in your Git repository, right? You have features that are partially coded or whatever. All of these things are in process. But if we stay focused and limit WIP, then we can do this, which is aside from focus on the work, not on the worker, is my second favorite lean phrase, which is stop starting and start finishing. If we simply do that, if we say what is closest to being done, and focus on that and actually get it done, that has enormous value in terms of allowing us to actually realize value in terms of potentially revenue, as well as potentially feedback, right? Those are two different ways we can see value. Now, simply trying to limit WIP can be very difficult, especially in a system where WIP is potentially run rampant. And again, by WIP, and this is could be a whole nother topic, but like WIP is anything that has started that hasn't finished yet. So sometimes people think of WIP or work in process as the things that are currently like have somebody assigned to them that's working on them. In this case, we're saying anything that's started that hasn't finished is work in process. So if somebody's written a document about it, or again, you can have, like we talked about in the kitchen example, different timeframes that you're monitoring for WIP. But if you're just looking at like, hey, we've given something to the developers to when it's deployed, let's say for an example, anything that has been started to work on or has any code written, like that's in process, even if nobody's currently working on it. Maybe it got set aside for something else, but it's still the work. Again, the work is in process, even if the workers aren't working on it. That being said, with that definition of WIP, again, if you like limiting WIP can be super powerful, but it can be super hard, and is if that is used as the metric or the goal that you're looking at, oftentimes WIP will start to hide. And so the metric that is often more useful to look at this point, if you're in a unbounded system to start out, is to focus on aging WIP. So meaning look at the things that have been in process the longest, the things that started the longest ago, and seeing, hey, should we, again, thinking about it as inventory, should we actually deliver this to a customer? Should we finish it up, do the last couple steps and get it out the door? Or maybe this inventory has expired and needs to be needs to be disposed of in some way, whatever that looks like. So again, if you focus on that older WIP, then that can help start to manage that partially done work. Okay, so number 1 is partially done work. Number 2 is extra features. This one isn't nearly as complicated or controversial, I guess, maybe, but you know, we've all experienced feature creep. Mostly, you just, you know, there's a matter of discipline, like shipping something, getting feedback, seeing actually people use it. Donald Ryerson says this: if there isn't a clear and present economic need for the feature, it should not be developed. This one is a hard one because we often are in systems where there are people with ideas about what is going to be great and what is important, and it is hard to forecast in the future what economic need there might be for a particular feature or not. But if we use that economic need filter, it can help us to better figure out what types of features we should be building. Okay, so that's the second one. Third one is relearning. So relearning can be focused on, okay, well, we learned something, but then we didn't write it down, and then so somebody's going to have to go relearn it. And so one aspect of preventing the waste of relearning is to document things, right? The problem is that documentation often goes into a binder on a shelf somewhere, either physically or, you know, again, in Confluence or something like that, and then is never looked at again. The thing is that that with documentation, I really like this phrase that I found around documentation, right? So this whole idea of relearning is rediscovering something we once knew and have forgotten. The problem with our documentation often is that it is often too verbose and far less rigorous than it needs to be. So the problem is we don't find a lot of value in the documentation, but we feel like we should, and so we put minimal effort into it, in which case we often tell too much or not the right things in our documentation, nor is it as it ends up being less useful, which leads to us not doing any documentation. Now, I'm on the camp of like very minimal documentation on most things, so figuring out the right things to document is really important to me because it is important to not have to continually relearn things. The more dangerous part of relearning that can happen is that we ignore it, right? So the previous one is like there's something we figured out and we've lost the handle on it. A lot of times people do know it, and we don't bring those people in terms of helping to make sure that we have all the knowledge in the room that we need. So people know things in our organizations, but we don't engage them in the process. And I would argue that this is even more serious than losing track of the knowledge that we've generated, is to not use the knowledge that we actually do know that we have. One of the techniques that I have used in my career over the last I guess at this point about 12 years is using mob or ensemble programming. This is defined as like getting all the brilliant people in the same room working on the same thing, and in this case in mob programming on the same computer. It's often referred to now as ensemble programming as well, but you can find resources on mob or ensemble programming. Even if we were to use pair programming techniques, that could also help us in a lot of ways in terms of getting more diverse viewpoints and more knowledge that we don't have to relearn. Okay, so the next thing is handoffs. So this is another form of waste. This one, I don't know. I mean, we make up silly games that demonstrate this, right? Like we have the game of telephone where like, okay, one person whispers something to the next person, they whisper it down the line, and we figure out how the message gets corrupted as it gets handed off between people. If you ever played Telestrations, this is kind of a fun, I take on the same type of thing where you get a prompt and you draw something, and then the next person has to take the drawing and write what they think it is. So the next person then has that prompt for their next drawing, and then eventually, again, the signal degrades over time and gets corrupted. And one more example is there's often this game you can play where essentially you sit back to back and you try to describe even a drawing to somebody and have them draw it, and then just kind of see how that turns out. But all of these things, again, have this idea of like we are in our own silos and we are needing to communicate, and which again is hard and is often necessary, but like transferring like context and knowledge can be difficult. If I were to ask any of you to describe, like in a written format, the written document, how to tie a shoe, it would be very difficult. And so if we want to do handoffs, we want to do them in as rich a way as we can, using interactive techniques as opposed to less rich communication techniques like simply writing stuff down. Because what often happens is that we can, even when we're talking, we might get to where we all say that we agree, but we all have different mental models in our heads. So it's very hard with knowledge work to really align on what it is that we're going to do. And so as much as we can, again, work together throughout a process so that people can continue to have context throughout, the less waste there will be in terms of handoffs. Okay, next up is task switching. So task switching is, right, the idea that instead of having a person on your team essentially assigned to one product or project or one team, you split them up and have them work on multiple different projects over the course of the week, or potentially multiple different tasks at once, and we need to get them all done or something like that. This is obviously a exaggerated version of this, whereas if you say, I'm going to work on task A and get that done, and then task B and get that done, task C and get that done, you get those done within 3 weeks in this case. And then, but if I say, well, I'm going to have to incur some cost of switching, then that extends it for another week because I'm trying to interleave things. I mean, we've all experienced task switching problems, and so there's a couple different ways to resolve that, right? One is to try to reduce the task switching at all, which is really good. But sometimes we're not always able to do that. And so one of the other things we can do is be more resilient to the task switching. I'm a software engineer, and there have been over the years many different people talk about like not interrupting programmers and how that like breaks their mental model and all these things, to the point where there was a Dilbert a few years ago that basically said, do you have a minute? It's like, I don't have the 15 minutes it would take to get back in the coding zone after your interruption. It's like, but I only need 1 minute. It's like, so the thing is that that 1 minute interruption actually causes 15 or 16 minutes of interruption because of the loss of context. Now, the thing is that what can happen is, so that's like at an individual level. Also, there's disruptions at a team level. Sometimes it's referred to as the bus factor, but I refer to it as the lottery factor. So like how many people on your team would have to win the lottery in order for you to irrevocably lose a piece of context or information or knowledge or about your system. And so again, this is another like having developers get interrupted, like is that micro task switching. You also have potentially interruptions, like, you know, people want to go on vacation and that should be okay. And even if they don't win the lottery. So how do we get better at that? So there's this idea of distributed cognition. And this is often, I don't know a whole lot about this field, but it is related, again, back to that mob or ensemble programming, that if we're working together on a problem, then no one of us maybe has all of the information, but we all have enough of the information to keep it moving forward. So again, just like I said before, right, you could have distributed cognition in all of these people. You could also, again, externalize some of that in terms of like sticky notes or documents on the computer. All of those things help in terms of maintaining cohesion over potential interruptions or switching. This is actually a little comic somebody put together almost as a contrast to some of the comics that were out there about don't interrupt developers, where if you're pairing, you're going to actually be potentially more resilient to interruptions because you both have the in mind, the context in mind, and can spur each other on to reform the context when you need to get back into it. Another technique that's useful, which is available if you're pairing or if you're mob or ensemble programming, is this idea of strong style pairing, where kind of traditional driver navigator is if the navigator has an idea, then they take the keyboard from the driver. But in this case, if the driver has an idea, you have the other person take it so that they can navigate. So the idea of strong style is specifically for an idea to go from your head into the computer, it must go through someone else's hands. This is an idea that Llewellyn Falco has socialized a lot. So again, all of those things can make us more resilient to switching. It doesn't necessarily reduce it or eliminate it, but it reduces the impact of it. Okay, we're almost done. I think we have 2 more left. So delays. So I can't remember where I got this from, but there's an assertion that developers make critical decisions about every 15 minutes. And for the most part, a lot of those decisions can be made by the developer by themselves. But if external requirements, approvals, information is needed, all of those things can cause delays. Like, you know, in my example, I didn't even have like the idea of like, okay, maybe three hours into fixing that particular defect, maybe they needed to wait for a product manager or some domain expert to be available in order to answer, well, this is how it's doing now. Like, what's the actual right behavior that it should be doing? And like, maybe there's just some complication there. And so if you have to wait for that answer, the longer you have to wait for that answer, again, the more potential waste you have in your system and the less the work is flowing. Right, but this also could be any sort of delay, right? It could be, in this case, like number 4 is like code to pass the test, right? If the test suite is taking a long time, that's also wait. If the build takes a long time, that's a long time to wait. If the pipeline takes a long time to deploy, there's all waiting times and all things that we can work on in terms of reducing waste. So the last one is defects. Defects are interesting, and the quote I like about this is revolving around how Toyota thinks about defects. So inspection to prevent defects is absolutely required of any process, but inspection to find defects is waste. So again, preventing defects is absolutely required, but finding defects is waste. So, right, there's a lot of different ways this can manifest. One of the techniques that I use in this case is using test-driven development, right? Because this allows me to write a test up front, find problems and make code sooner, and so anything that allows us to kind of shift when we find defects sooner, to again prevent them from leaving our system and not causing disruptions coming back in later, is going to be better in terms of our flow efficiency. And so these are our 7 potential wastes, right? And each of you may have more or less need to focus on any given one of these in any given time. Obviously, the ones that I probably talked about more are ones that I've experienced more and had more success in eliminating. But you know, again, looking at your system, you want to look for these types of waste and see what you can do to eliminate them. Okay, so we said lean is focused on flow efficiency. So let's go back and answer that question. What is lean then? Right? We talked about lean as this high flow efficient and high resource efficient state, and that pursuing that flow efficient state is the goal, right? Now, I'm just gonna there's a story of this man named Uwe-san that was from Toyota, a manager at Toyota, that went and was invited to go and see a European engineering company. They gave him a tour and showed him all the things they were doing that was so awesome. And they kept waiting for him to say, "Oh, that's great, that's great." And so at the end, they said, "We have shown you the whole factory and told you about all our work on lean, which we're very proud of. We were wondering now if you consider this to be world-class lean," right? Because they're like trying to get the approval of this guy from Toyota. And so his answer was short, to the point. He said, "It is impossible for me to say. I wasn't here yesterday." So a large component of lean, what we've talked about today is kind of like setting that North Star. The component of lean is this idea of continuous improvement, of like continuously finding new ways to potentially reduce waste or become more flow efficient using other techniques that we haven't talked about today. So I would encourage you to stop starting and start finishing. Having a bunch of projects in flight might sound exciting, might make things seem busy, but will inevitably lead to delays across all the projects that are in process. So stop starting and start finishing. And again, like I started, focus on the work, not on the worker. And if there are any questions,